Good morning, Barcelona. My name is Voermans. I am one of the IoT Solutions World Congress Program Committee members responsible for bringing you all this good stuff. I want to introduce you today to a last minute session that we have been able to squeeze in. Sander van der Velde, he brings in over a decade in developing, designing and deploying IoT solutions, bringing business value with complete data streams. It's going to be a technical session with an overview of a complete data flow, but without further ado, Sander, take it off.
Well, Edward, thank you for the kind words. Let's continue with the presentation about Azure IoT operations and bringing insights, real-time insights and conversational AI from edge to cloud. Here it goes. My name is Sander van der Velde, and I'm a senior architect at SDG Group. I'm also a Microsoft MVP due to my community contributions about Azure IoT and real-time intelligence for the last 8 years. The SDG Group is a company who is specialized in AI, data analytics, machine learning, and together with my colleagues from the Alten Group, which is specialized in offering consultancy to companies in the high-tech sector, we can do a lot with IoT, bringing value through insights based on devices. We have an office here in Barcelona. Well, you obviously have seen that I'm not actually a Barcelona person. I'm from the Netherlands because we are a global company. I have more than 2,000 colleagues, and we offer services to more than 700 customers. We will look into 10 years of IoT and what the future will bring, including Azure IoT operations. And I will have a demonstration, a recording of a demonstration about bringing insights and conversational AI both on, based on edge and cloud compute. If we look at the last 10 years, what Microsoft has offered with a generic cloud, it started somewhere in 2016 where they offered a IoT hub, a cloud gateway where devices can connect securely to the cloud based on the 7 habits of highly secure devices. So what they offer is each device has its own identity, its own security keys. There's a secure channel to communicate, and over that channel you can send both telemetry and receive commands. And almost at the same moment, Microsoft also offered an edge solution for running compute locally and having that controlled from the cloud, zero touch. And we still use it for many customers, and we actually start new projects with it. But if we fast forward, last year, Microsoft introduced a number of new services, like a new cloud broker, but which is specialized in the MQTT protocol. They offered a completely new data platform called Microsoft Fabric, which is no-code, low-code, self-service data data platform where you can create resources in the cloud and have data in it and, well, display it and react on it. And Microsoft also came with a new edge solution, a second edge solution, which is the newest member of that family of IoT solutions. If we look back for the last 10 years, it's a little bit like playing with Lego. We had all these platform as a service solutions, components in the Microsoft Cloud, in any generic cloud, but this is the Microsoft Cloud, where we have that gateway, we have databases, we can run compute, logic apps, we can send email alerts if needed, and we can work with time series data. And we also had Lego on the edge, because the edge solution that Microsoft is offering, Azure IoT Edge, is based on Docker containers, and each Docker container is also working with kind of a mailbox system for receiving messages and sending messages. So I, as a composer, as an IoT administrator, I can make a connection between these pieces of Legos as if they have the right knobs on it. But the IoT landscape has matured over the last 10 years. It's not anymore about having hardware connected to the cloud. Can we do that? It's about the value proposition. What is the value? What are the use cases that customers want to have built? And so we can add value with insights, real-time insights, almost sub-second level insights. That's a completely new, strategy for many customers, so they know what their machines are talking. Customers want to have the IoT platform built in with many personas, like an IoT administrator, an OT administrator, or an OT operator, and there's also this data engineer suddenly. They are asking for the implementation of new protocols and other standards like MQTT, OpenCUA, or Kubernetes. And customers are also asking for implementation and integration with other data platforms. It's not Microsoft only. They want to have their data sent to many destinations. And there's this requirement that an edge solution should be resilient for failure. So failover, high availability, running the same piece of compute on multiple pieces of hardware, like industrial PCs. This is something that customers are requiring. So if we look at the new edge solution that customers are asking, at a high-level architecture, we see that they want to have OT and IoT separated. They have their own different roles, their own different features, and with that, on the edge, they want to connect with many protocols. So they need a message bus which is open. In this case, we will see that we are working with MQTT, a very available and open standard of communication protocol. The OT administrators want to have access to all the assets and the protocols and devices behind it on the local network. And there are questions from administrators and data engineers to have a northbound connection towards the cloud to other data sources to send the data to. And of course, there's this ask for a reliable solution with failover. So if one industrial PC, one node fails, the load will be taken over by the other nodes without losing any data. So let me introduce you to what Microsoft has as an answer for this, and that's called Azure IoT Operations. From a cloud engineer, so an IT guy, they can control the industrial PC or the node, the cluster of machines, as if they are VMs in the cloud. And also, it's running Kubernetes. The Kubernetes cluster is acting as a member of the cloud. So an IT guy knows how to work with this. This is based on Azure Arc, a bridge between many services, the real world, the cloud, or multi-cloud. There's the OT engineer who is interested in connecting assets, devices, getting the data in, maybe sending the data also back to other devices. They have their own portal and they can do this remotely. And then there's the data engineer who says, well, if there's data in the machine. How do I get it? Here are my resources, and also remotely we can set up that connection. Actually, the edge has its own identity in the Microsoft Azure cloud. So with that managed identity, I can make a secure connection to a role-based access control access to resources outside the edge in the cloud. Well, this is a really interesting story, of course, many slides and many diagrams, but how about an actual solution? And for this, I have set up a demo factory. It has a Teltonika router, a 4G router, for having a connection to the internet, to the cloud, and it controls the local network. There's an industrial PC from Advantech, which is a beefy device that can run Kubernetes, and it can run Azure IoT operations. And it can be created, you can have multiple, and then have a cluster of devices. I have put in there a Wago PLC with an energy meter, which can read the Azure current and voltage. And I have a jump box, a panel PC from Advantech, which offers me access over a secure channel to the local network for doing stuff. If everything else fails, I can still access the local network this way. And because OnVIF, a protocol for cameras, is also available, I put a camera in there also. And it gives me nice pictures like this, so I know a little bit what's happening locally. So this is the setup. And on that setup, we have a use case where we take the energy meter data, we send it to the local broker on the edge, we enrich it a little bit and send it to the Microsoft Fabric data platform. Unfortunately, I'm not able to give a presentation here, so I made a recording with subtitles, and well, let's watch it. I will explain some things later on.
We are looking at the Azure Arcs feature in the Microsoft admin portal of the Azure Cloud. Here we can manage machines, Kubernetes clusters, Azure IoT operations running on Kubernetes clusters, and assets behind Azure IoT operations. Regarding the machines, here we see that I've connected 4 machines. 2 of them are Azure IoT operations solutions, and 2 of them are my jump boxes. The jump box gives me access to the local network in a secure way. I can update devices, I can apply policies, but I can also make a remote connection using SSH. Once that connection is set up, I can go to the device. I can actually do an RDP session over SSH, and we are looking at the setup on the local network. I can actually log in remotely to the other machines on the same network. So on the device we have Azure IoT operations running. As an IoT administrator, I can manage the Azure IoT operations cluster in the Azure portal. For example, I can manage the settings of the broker, the MQT broker running locally. I can also manage the data flows for MQT messages coming in, going out, or being exchanged between topics on the MQT broker. Once Azure IoT operations is set up, we can use the Azure IoT operations experience as an OT administrator to discover assets or add data flows. In this case, we have discovered a OpenCV server which is exposing tags like humidity, pressure, and temperature. Those values are sent to the local MQT broker, so we need to pick them up and send them to some other destination. For that, we use data flows. There are many endpoints available. There's the local MQT broker, but there's also, for example, a Fabric connection with Microsoft Fabric or with Azure Data Explorer. In this case, we forward the energy meter information from the local MQT broker towards the Fabric event stream. So we have set up the source, the MQT topic. We have added some compute. In this case, we enrich it with the universal namespace, and we have set up the endpoint with the topic of the Kafka endpoint in the Microsoft Fabric environment. Microsoft Fabric is the new low-code, no-code self-service data platform for handling data workloads. It also comes with a very extensive set of tooling for handling real-time data. The Azure IoT operations workflow is forwarding telemetry, energy meter telemetry, to an event stream living in this workspace. In this workspace, we see the endpoint, and we see that the same data is sent both to an activator for alerting and a timeshift database for recording historical information and querying it. Microsoft Fabric offers a really powerful time series database. It's called the Event House, and in there we can have tables inside databases. At this moment, the raw telemetry from the energy meter is sent to a table called energy meter, and we see we get JSON messages. To make more use of these messages, we use a medallion architecture to forward the messages automatically to new tables. We see here the current energy table and the voltage energy table. These are typed, and we splitted all the information. With the database also comes a very powerful query language. And at this moment, I can search through all the messages, and we see that we have a current wattage of 34. On top of the real-time data in the Event House, we can build real-time dashboards. In this case, we see two widgets with the most recent current and voltage information. We can hover over the values, but we can also add alerts in case we see something which we want to be noticed about. And we can explore the data to drill in even more into the data using a no-code experience. Last but not least, the Microsoft Fabric environment also offers us the uses of agents, AI agents. We can feed them information from tables like the current energy meter information and the voltage information. We can give some instructions in plain text about what this data means, and we can ask them questions. For example, let's ask the agent about any recent outliers in the current table for a factory in Helmond. It says there are no outliers found. Let's see how that is done. Well, it comes with a solid query based on anomaly detection on series. So that's fine. This means we can chat with the agent about the data, and we have actually a conversation with our data and with our machines.
Yes, sometimes you're lucky, you have some anomalies. In this case, in the demo I had none, but you have seen that there's a solid query behind it. So even people without any knowledge about real-time data or with time series databases, they can work with the data that we've seen. So what we've demonstrated is that we can use Azure Arc to work with remote machines and with Kubernetes and also SQL Server as if they are living inside the Azure cloud. We have seen that there is something called a local MQTT broker. In this case, we see some tooling that we normally use to look at the messages that are flowing through, if we have the right rights, of course. And in this case, data from this energy meter was collected. It's a Modbus device, and with Node-RED, it was changed into an MQT message sent to that MQT broker. That message was then sent, picked up by a data flow and sent to the Microsoft Fabric data platform. And we can actually do some enrichment, like adding compute, what I did here. I took the topic, split it up, and that's what I sent to the device. We can filter, we can add extra properties. And once the data comes into the Fabric Cloud, well, it's the job for a data scientist to do something with it, or a data engineer. And that can be done with this no-code, low-code experience, like it's Power BI. And we've seen that there's a database available for time series data, which is perfect for time-related events, observations, like logging, like security audits, immutable. Azure Data Explorer under the covers in Azure already offers this. Microsoft has added it to Fabric. If you're working in Azure with log analytics or with Microsoft Defender, you know this. You've seen this because it's the same tool. We can put alerting on it. We can put real-time dashboarding on it. But not only this, but also Power BI or Grafana or any other tool can be used for that real-time data. And last but not least, we've seen that we can use AI agents to have a conversation with our data. So the key takeaways is that IoT is maturing. And it's now based on standards, de facto standards from all parts in the world. Microsoft is offering a stable and multi-node edge solution which can offer failover as the big brother of, in a positive way, of Azure IoT Edge. We can use conversational AI on top of what a data scientist or a data engineer is already offering with ease, because even I can do it, so you can certainly do it. And last but not least, real-time data and real-time insights is really a game changer. We now learn about what our machines are talking, but the enterprise is also discovering this information from the factory into those enterprises. But in general, we can now see what our customers or our employees are doing in real time, with logging, with sales information, with security audits. So we are, the IoT persons here in this venue, are doing this for the last 10 years. And we have a head start on doing stuff with real-time insights. And with that, I will conclude my presentation. Edward, do you have something to add?
We are ready for some questions, if there are any. If not, then we conclude the session.
I am available in the hallway afterwards, so if you have some questions or you want to, well, talk with me, I'm available on this event.
Thank you.